All right, now we are going to do similar triangles. Last 4 days, this semester kicked off with congruent triangles, and today we're going to be talking about similar triangles, okay? So, again, everyone should have headphones out of our ears because we're paying attention and our eyes are wide open because we love math and geometry because Mr. G is the coolest teacher you've ever heard of, right? So, let's talk about similar triangles. Similar figures are the same blank, but not the same blank. Now remember, congruent was same size, same shape. But similar means same shape, but not the same size, okay? So again, similar does mean the exact same shape. However, similar does not mean the same size. It is a different size. Basically, it gets the same, basically you zoom in on it, or you zoom out on it, okay? That's it. It's either bigger or smaller, but it's the same exact shape. So let's look at these pictures here. Blank, the two triangles above are similar triangles. The way that we say this in math, notation, is with the following similarity statement. Okay, so we're going to make a similarity statement. And we're going to say triangle ABC is similar. And here's I think we've talked about this little symbol before. But the symbol for similar is that. Okay? It looks like a squiggle. But instead of saying squiggle, do y'all remember what we call that thing? It's called a tilde. Tilde, right? So that means similar. Okay. To what? So again, order matters. If I said A, B, C, then I need to say D, E, F in the exact same order. Triangle D, E, F. Those two triangles are similar. Okay. Cool. And that's what it says right there. So we read this as triangle ABC is similar to triangle DEF. All right. Now we want to study the triangles above to fill in the blanks below, and we're going to use proper notation. So I'm going to have to kind of go up and down here. So angles A, B, and C are congruent or equal to angles D, E, and F. So let's fill that in. Angle D, angle E, angle F. Okay. A goes with D, B goes with E, C goes with F. And then up here, what is angle A and angle D's measurement? They're both 25 degrees, the exact same measurement, right? So let's put that down here. And by that I meant to do this, sorry. 25 degrees. And then what about, so C and F are both 41. How do I figure out that third angle? What do they add up to? 180, right? So I'm going to take these two, add them up, and subtract it from 180. So let's do that. 25 plus 41 is 66. Subtract 66 from 180, and I get 114. Okay? So 114 degrees is E and B. So let's write that down here. 114 degrees. All right. And then for our sides, AB over DE. So AB is 4, but DE is not 4, right? It's 6. Now we're going to make that into a ratio or a fraction. So AB is 4, DE is 6. We're going to write 4 over 6 in that little fraction bar. 4 over 6. Okay? Now, what is 4 over 6 reduced to? 2/3. Okay? 4 over 6 equals 2/3. Great. Okay, the next one. So we're talking about BC and EF. BC is 2. EF is 3. 2 over 3 is, well, 2 over 3, right? Obviously, it doesn't reduce anymore. And then last but not least, AC over DF is 5 over 7.5. Now, if you were to divide that in your calculator, okay, you would get probably the decimal 0.6 repeating, but guess what that equals? 2/3. Okay? What do you notice about every single ratio? They're all the same. 2/3. Or they would equal the same decimal, right? So since they're all 2/3, okay, we know they're similar. So over here off to the right, the number, this fraction, this ratio, is called the scale factor. Okay? So, since all these sides give you the same ratio, we say that the sides are the P word, proportional. Okay? And we're going to see how that works here on the next page. So make sure you filled that in and flip it over onto the next page. I'm about to change it in 5, 4, 3, 2, 1. All right. So on the next page, conclusions about angles and sides. When two triangles are similar, their angles are always what? So from the front side, remember the angles were always the same, right? They're congruent. For sure, the angles are going to be the exact same for each similar triangle. Then it says, on the second part, when two triangles are similar, their blank are always blank to one another. Their sides are always, and that's that P word, proportional to one another. So this means that if you set up corresponding sides as ratios, the ratios are always equal to the same number. So again, this means that if you set up corresponding sides, okay, you're going to get the same ratio. It's always going to be the same number. We're writing similarity statements. Now check this out. Like we've said all week, order matters, okay? So the angles must match up. Which of the following is not a correct similarity statement for the triangles below? So notice, these are similar triangles. B and D are corresponding. C and E would be corresponding, so this should be 33. F and A should be corresponding, so this should be 98. Okay, so are these similar statements? We're going to put yes or no, or we're going to cross them out if it's no. So look at the first one. A, B, C, D, E, F. Does A correspond with letter D? So A is 98. What's letter D here? 49. Does this make sense? No, because the order matters. Angle A does not correspond with angle D. Okay, what about the next one? Angle C corresponds with angle F. C is 33. F is 98. Does that correspond? No. Okay, on this one, angle C, angle F, same exact problem. C is 33. F is 98. That's also no. No, no, no. Okay? So you see how those don't work because the order matters. I know on your notes there's little boxes there randomly that's supposed to be triangles, okay? So make sure these are little triangles. Okay? Now, let's do at the bottom where it says solving for a missing side, okay? Okay, it says since you know that sides of similar triangles are proportionally related, you may have to set up a proportion to find the missing side. Okay, you should have done this before, where you make two fractions, you set them equal, and then you do what we call either cross multiplying and dividing or butterfly method. Either way, we're going to show you how to do it right now, as long as you're paying attention, not on your phone, right? So, all right, first one. First step, every time you're doing one of these problems, is you need to connect corresponding sides. So go and write this down. Connect corresponding sides. So here's how you can do that. I see 3 corresponds with 4.5, so I draw a little arc to it. I see 5 corresponds with x, so I draw a little arc to it. Okay? I'm literally connecting them with either a line or an arc. That way I know what my fractions are going to be. So whatever you connect is going to be a fraction. So 3 is going to be over 4.5. Let's write that down. 3 over 4.5 equals, and then I have 5 over x. So now what we do is we cross multiply and divide. So I got 3 times x, 3 times x, equal sign, and then I got 5 times 4.5. Now all I got to do is actually multiply them and then divide by the coefficient. So 3 times x on the left side is 3x. 5 times 4.5 on the right is 22.5. And then I'm going to divide by that coefficient 3 on both sides. 22.5 divided by 3 is 7.5. I did it earlier, but yeah. On the next one, let's do this one together. We're going to do the same exact idea. So first step was to do what? Connect the corresponding sides. So what does 3 connect with? 6. And then 7 connects with x. Make your two fractions. Okay? 3 over 6 equals what over what? 7 over x. Once you set them up, cross multiply and divide. So 3 times x equal sign 7 times 6. And then we just got to do the multiplying and then the dividing, right? So 3 times x is still 3x. 7 times 6 is 42. And then we divide by that coefficient 3 to get 14. Okay? So again, step 1, connect them. Step 2, write your two fractions with an equal sign. Step 3, cross multiply. Step 4, divide. That's it. Anytime we have similar triangles, that's how you do it. Okay, let's try an example on the next page. Okay. Next page has a little bit different question. It says, are the following triangles similar? If it asks you, is it similar, you're going to make all 3 fractions and see, are they all equal? But first, does everyone see how these two triangles are not exactly the same direction? They're similar, but this one right here needs to be kind of rotated to the left. So what I'm going to do is I'm going to redraw this triangle right here to match the big triangle on the left. So it's going to look like this. And again, I'm rotating it, so it's actually going to be E here, letter D here, F over here. And I'm going to relabel it as 3, and then 4, and 6. Okay? Now, I'm going to kind of ignore this original one right here because I redrew it over here. And what was my first step? Like before, I'm going to make my arcs. I'm going to connect the corresponding sides. What does 9 correspond with? 3. What does 12 correspond with? 4. And 18 goes with 6. So here's what I'm going to do. I'm going to make all 3 of those fractions and see, are they equal? If they're all equal, then it is similar. So first one was 9 over 3. The second one was 12 over 4. And then the third one was 18 over 6. What does 9 over 3 equal? 3. 12 over 4 equals 3. 18 over 6 equals 3. Since all 3 of them are equal to each other, they're proportional, so we can say, yes, the triangles are similar. Okay? So again, if you ever get asked this question, are they similar? Make your 3 fractions, see if they're all equal. That's a yes if they're all equal. Okay? Let's do number 2 real quick. Number 2 should be kind of easy. On number 2, we're going to set up our 2 arcs, right? What does 11 correspond with? 35. 4 corresponds with x. So 11 over 35 equals 4 over x. And then we're going to cross multiply and divide. 11 times x over here equals 4 times 35. 11 times x is 11x. 4 times 35 is 140. And then we need to do 140 divided by 11. Okay. 140. Oh. Let's make this bigger. Okay, Control Enter. 12.73. Okay. So even if you get a decimal, that's fine. Okay. All right, this last one, number 3. On number 3, you see that there are 2 triangles, but one's inside of the other, right? So here's what we're going to do. We are going to draw the small over the small one, okay? So we see that this is 7 and 9, right? But what I'm going to do is redraw the big one over here, and I need to relabel it, okay? I'm going to do that a little bit better. Okay, so what is the bottom length of the whole big triangle? Okay, 17.5. But now I want you to put on your thinking caps. This is going to take a little thinking. What is the side length of the whole big triangle? Okay, so we don't know if this is 9 as well. So we don't want to say 18, and then someone said 9x, but that would be multiplying. Instead, what you want to do is add the 9 and the x. Now, when you add 9 plus x, they don't combine. So literally, we're going to write, parentheses, 9 plus x. Anytime you have a variable and a number, you write them like that. They don't combine. They're not like terms. But now, we can actually connect them. So 9 corresponds with 9 plus x. 7 corresponds with 17.5. And even though we have a weird length, we can still do this the same way. So let's do it. 9 over 9 plus x equals 7 over 17.5. And then we cross multiply and divide. 9 times 17.5 equals, and then how do I write this? Just remember, you got to use parentheses. So I'm going to do 7 parentheses 9 plus x. That's how you write it. Okay? Again, it's kind of weird, but you can do it, because now we're going to do the multiplication. 9 times 17.5 is 157.5. And then, what do we do right here with this parentheses in this number? Distribute. 7 times 9 is 63. 7 times x is positive 7x. Okay? Now, hopefully that looks somewhat familiar, because first semester we definitely solved for x a lot. And all you got to do is do a two-step problem. First, we get rid of, on the right side, which number? The loner is 63. So let's get rid of 63 by minus 63. Minus 63. 157.5 minus 63 is 94.5 equals 7x. And then our last step, to get rid of that 7, we divide by 7, and we get 13.5. Okay? So even if you have a weird problem where there's a two-termed, expression, you can still solve it. Okay? And that's how you do those. So what I want you to do is flip to the next page. I want you to get some practice doing these proportions. Okay, so that's your goal for the rest of class. Knock these out. Okay, go ahead and get started on that.